I am Shalucho Gangopathay from the Department of Mathematics, St. Xavier's College, Kolkata. I would like to thank everyone present here today for taking out time from your busy schedules to join us. In the last 2 years, our world as we knew it has changed drastically. The coronavirus pandemic has adversely affected the lives of millions across the world. As the entire world recovers from the blow of the Omicron variant of the coronavirus, we look forward towards a brighter and bigger future for all of us gathered here. It's said that the night is always darkest just before the dawn. With that in mind, the Department of Mathematics at St. Xavier's College, Kolkata continues on its relentless path to impart knowledge and change lives. In these times of despair, we have all looked towards the light of education to guide us. As part of this endeavor, St. Xavier's College has been an active participant in spreading knowledge and ensuring growth academically, personally, and professionally for all its students and faculties throughout these tough and testing times. As a tribute to this recognition, I feel proud to say that our college has been ranked 4th by the National Institute of Ranking Framework, Government of India. We have gathered here today for an e-colloquium presented by the Department of Mathematics. Our webinar today would focus on the importance of algebra in cybersecurity. With the data revolution of the 21st century, effective cybersecurity has become inevitable. Cybersecurity is important because it protects all categories of data from theft and damage. This includes sensitive data, personally identifiable information, protected health information, personal information, intellectual property, and government and industry information systems. Without a cybersecurity program, any organization cannot defend itself against a data breach, which makes it an inevitable target for cybercriminals. To illuminate us on this very interesting topic today, we have as our speaker, Professor Avishek Adhikari from the Department of Mathematics, Presidency University, West Bengal, India. As we traverse through this webinar, I would like to tell you some housekeeping rules in general. Everyone present with us over Zoom is requested to keep their video and audio off during the entire duration of the webinar. I request everyone on Zoom to ask questions only through the Zoom chat box. Everyone on YouTube is requested to ask their questions through the YouTube chat box only. We would be answering questions only at the end of the webinar, subject to time availability. I would once again like to thank everyone for being here with us today. With this, I would heartily like to welcome our principal, Reverend Father Dr. Dominic Savio, S.J. Father has been a tremendous source of inspiration for all its students and faculties. It gives me immense pleasure to say that Father Principal has been awarded the Shiksha Ratna Award 2021 by the Department of Higher Education, Government of West Bengal. With this, I would like to call Father to grace us with his presence, deliver the inaugural address, and initiate our program. Over to you, Father.
Thank you. Thank you very much. A very good evening to all of you. Dr. Avishek Adhikari, Dr. Sucharita Roy, the head of the Department of Mathematics, and all the respected professors and our very dear students. Once again, a very good evening and a warm welcome to everyone attending this e-colloquium on the topic, Importance of Algebra in Cybersecurity, which is being hosted by the Mathematics Department of our college. As we all know, cybersecurity, often known as computer security, refers to the safeguarding of computer systems, back-end systems, and end-user applications, as well as the people who use them and the data they hold. All parts of our life are becoming increasingly digital. Cyber attacks are typically used to gain access to alter or delete sensitive information, extort money from users, or disrupt normal corporate activities. In their pursuit, the attackers are becoming increasingly inventive. As a result, research is important and desirable. As we all know, cybersecurity involves a lot of mathematics. Basic high school understanding to concepts such as calculus, binary, number theory, Boolean algebra, linear algebra, and cryptography are relevant in figuring out creative solutions for the work. Today, it is heavily reliant on sophisticated mathematics to address challenges, particularly in new technologies such as machine learning and data analytics. Today, we are very much privileged to have with us Dr. Avishek Adhikari, professor at the Department of Mathematics, Presidency University, our alumnus, and a distinguished alumnus of our college as our guest speaker. We appreciate Professor Adhikari for your presence and thank you very much for being here today. As we all know that our college has produced brilliant brains who proudly represent us around the world. This day's setup is motivated by the unwavering spirit of dedication, the sincerity in the atmosphere, and the promotion of learning beyond textbooks. When the difficult time throws the toughest challenge, the human brain evolves with the most suitable solutions. Probably this is one of the fundamental laws of evolution. As witnessed by us in the years of the pandemic, whenever we stopped being innovative in our pursuits, teachers and students have come closer with the help of digital technology, and that motivational journey is still continuing. I would like to thank the Department of Mathematics, the head of the department, all the respected professors, along with our brilliant students for organizing many more of such a seminar. I would want to congratulate and express my sincere thanks to the entire mathematics department under the headship of Dr. Sucharita Roy and the organizing team for putting this e-colloquium together and directing it with a lot of effort. I should not take much more time anymore. I wish the webinar all success and wish you all the best. Have a wonderful, very good evening with Dr. Avishek Adhikari. Thank you very much. May God bless you. Thank you.
Thank you, Father, for such an inspiring speech. I would now like to call Professor Sucharita Roy from the Department of Mathematics, St. Xavier's College, Kolkata, to introduce Professor Avishek Adhikari. Over to you, Professor.
Thank you, Shatucho. A very good evening to one and all present here. I, on behalf of the Mathematics Department of St. Xavier's College, Autonomous, Kolkata, cordially welcome you all to this e-colloquium, a novel initiative taken by the Mathematics Department. I'd like to take this opportunity to express my sincere regards and gratitude to Father Principal, Reverend Dr. Dominic Savio, for his constant guidance and unstinted support in this regard. I deem it a great honor and privilege to introduce Professor Avishek Adhikari, Professor, Department of Mathematics, Presidency University, Kolkata, the speaker for today's e-colloquium. I would like to extend my heartfelt gratitude to Professor Adhikari for accepting our invitation and giving his consent to deliver a lecture in this e-colloquium in spite of his extremely busy work schedule. Professor Adhikari is one of the leading cryptographers in India. His research areas range from cryptography to graph theory, from network security to discrete mathematics. Currently, he is the HOD of the Department of Mathematics, Presidency University, Kolkata. He is a distinguished alumnus of St. Xavier's College and a gold medalist in MSc in Pure Mathematics from the University of Calcutta. He received his PhD degree in cryptography from ISI Kolkata under the supervision of Professor Bimal Kumar Roy. He received the prestigious INSA Young Scientist Award in the year 2006. He has research collaborations with various reputed institutes and premier organizations of the country, Defense Research and Development Organization, that is DRDO, Indian Navy, are to name a few among them. He was also the former Eastern Zonal Coordinator of the National Board of Higher Mathematics. Professor Adhikari is immensely popular among students for his lucid way of explaining intricate details to young audience. He has authored more than 50 papers in journals of international repute, and several books at undergraduate, postgraduate, and research level. He has guided 5 PhD students, and 7 more are working under him currently. Today, we are fortunate to have him with us for delivering a lecture on the topic, Importance of Algebra in Cybersecurity. This talk focuses on how cryptographic primitives can be used to provide some important information regarding cybersecurity and attempts to explore how much number theory and abstract algebra play important roles in this scenario. So without any further ado, I once again welcome Professor Adhikari to this webinar. Over to you, sir.
Thank you very much. Firstly, I'd like to thanks to the organizer for giving me an opportunity. It's like coming back home. I was, as I already mentioned, I was a student here from 1996 to 1999. And I'm fortunate that DS sir is already present in front of me. It's a kind of inspiration for me. And father is also there. Thank you, both of them. So basically, today's talk, I will basically highlight mostly on how algebra could be useful. So as you all know, and already mentioned by father as well as Sucharita, that how cybersecurity is important in our today's life. So I'll basically highlight few of the applications, as already mentioned by Sucharita, that mostly UG 1, 2, and 3, as well as few students from other departments will also join. So I will try my best to make it as lucid as possible. And if any questions that you will have, please do not hesitate to ask me. It could be an interactive way of session. I prefer most the interactive way of going on. So if you have any questions or doubt, please do not hesitate to stop me at any point of time. I will love to or try my best to resolve the questions. And yeah, so without any further talk, let me directly go to my technical part of it. Since, as I mentioned, I just logged in from my Linux machine, that's why only one Windows could be shared here. So whenever I will switch to my other window, I need to make it manually. Okay, anyway, but I will do that. So yeah, share my screen. Yeah, is my screen visible? Okay. Yes, as you can see that the title of my talk is Importance of Algebra in Cybersecurity. So when I was a student like you, most of the time that haunted me most was, is there any application of algebra in our real life? So at that time, I didn't find much, but even when I was doing my master's, at that time also, it was not quite clear to me how this abstract looking subject could be that useful. But when I joined to Indian Statistical Institute and when I started working on cryptography, the idea came to, I mean, it's quite clear to me that, okay, though it looks quite theoretical topic, but it has lots of immense application in our day-to-day life. So in today's talk, I'll basically try to highlight few of them. Of course, it's not possible to explore all, but I will try my best to make it in a concise way. It should be a kind of self-contained way, so that we will all understand what is exactly or which part of it is exactly and how it would be useful in our day-to-day life. Okay, so before I start, let me first go through a very simple statistics. So there is no doubt that in today's world is full of digital data. Our mind, our brain are full of digital data. So let's start with some statistics. Statistics is a kind of mobile internet users in India. It's a comparison between urban versus rural. So this figure, this diagram is basically in millions, and it starts from June 2012 to June 2016. So if you look at with respect to this mobile internet users in India, it was around 48 million users were there, out of which 44 were from urban area and only 4 millions were from rural area. So it's average around, or if you have a ratio, it's around 1:11. The situation goes little better, and if you consider in 2016, the total user were around 371 million, out of which 109 millions are from rural area and 262 are from urban area. So in 2016, this ratio is around 1:2. So from 1:11, it becomes 1:2. So within this maybe 4 or 5 years of span. So if you go a little beyond, it's basically the total monthly wireless data consumption, and it's again from 2014 to 2017. And it was going steadily, and suddenly in 2016, it had a big jump. And if I ask you this question, any reason? Can anybody be able to tell me? Are the audience mostly muted? So then you may not be able to answer. Well, yeah, I'm sure that you all have understood that what is the reason behind it. This is nothing but this Geo. Due to this Geo company, the monthly wireless data consumption increased a lot, and it's from like this to kind of exponential growth of it. If you look at little more details about the statistics, but it's little older statistics, 2019, and it says that Google processes over 5 exabyte of data per day. So what is 5 exabyte? 1 exabyte is 10 to the power 9 GB. So can you believe that? 10 to the power 9 GB. We can think of 1 GB, maybe 1 TB nowadays, but it's 10 to the power 9 GB. That means in one day, Google processes 5 into 10 to the power 9 GB of data, that too in 2019. So it's pretty old data, but still it's 5 into 10 to the power 9 GB per day. Google handles 1.2 trillion searches every year. 1 trillion means 10 to the power 12. And I'm sure that this search process has been increased manyfold by this time. Facebook generates 4 petabyte of new data per day. 1 petabyte is 10 to the power 6 GB. So that means 4 into 10 to the power 6 GB of data every day. 350 million photos are uploaded per day. Users generate 4 million likes every minute. So just imagine it's in 2019. By this time, it has increased manifold. WhatsApp is also doing quite well. WhatsApp has nearly 500 million users. It processes more than 70 million messages a second. Okay, so 70 million messages. So you can understand that huge amount of data are being consumed every day. So that's why people nowadays, they say that it is on 2006, Clive gave us a nice expression of this: data is the new oil. So it's in true sense, data is a new oil. So in today's talk, since we do have many mathematics students, so I have not decided to talk much on this, why I say that, or why he says that data is the new oil. Just for a side note, like you can understand that if I ask you a very simple question: have you ever paid Google for any of your personal works that you've done through Google? For example, you may say that, okay, I pay some money through Google Pay, so that means I have paid to Google. But if you look, or if you read carefully about the write-up for Google Pay, they say that they don't take any money from the person who are paying the money, but they take the money from the merchants. That means you do not pay the money directly to Google for any of your personal work, like email, storing data, storing images, or Gmail, or Google Meet for maybe nowadays it's for 1 hour or something for free versions. So there are plenty of things that Google offer with free version of it. But if you look at very carefully, that still without giving such a kind of big support to all of us, Google is still one of the richest companies in the world. So the question is, Google provides us so many free gifts, but how can this company be so rich? So if you go in a detail, I can show you, but in today's talk, I have not decided to say anything on it, because one very simple thing that I usually prefer to look at, or I sometimes give my students to work on it, is the question is how Google tracks us. Like if you have a mobile with a smartphone with your Gmail on, and if you have internet, then Google is tracking you second by second. So you can see at your profile that how much Google knows about you. Okay. It's a huge data that Google is collecting about you, and you may not know a unique number of your mobile, but Google knows that what is the unique number of your mobile. That's not your mobile number, but a unique number. There's a special name. I'm not going to the details or technical details about that, but the point is Google knows many things about it. What is your preferences, what searches that you are doing, etc. Every huge data they're collecting for every email ID. That means they are characterizing you, and based on your nature, Google is supplying this data to the companies so that dedicated or targeted advertisement. So there are some softwares called boosting software, like advertisement boosting software. Depending on your search, the advertisement will come to you. That means a dedicated or targeted advertisement will come to you. As a result, for the merchants, it's very easy to sell the product. That's why nowadays you might seen that the big newspaper companies, as you all know, in Kolkata itself, you all know that in West Bengal, one of the largest or biggest newspaper companies, they are also nowadays finding it that the challenges, because the advertisement that they usually get around 5 years back, they are not getting that much advertisement for ordinary people, because if you pay much less amount of money, and you will able to show your advertisement to a larger class of dedicated or targeted audience. That's why for the user viewpoint also, it's very easy to pay less amount of money to Google and not to the big newspaper companies. That's why, depending on your data characterization, as at the beginning of my talk, I mean, even before my talk, the father already mentioned about analytics and AI. This technologies and this kind of mechanisms are being heavily used nowadays to characterize a people, so that depending on your nature, you will get the advertisement for you. That's why the data is a new oil. So I could have shown you a lot of things, that how exactly Google tracks you, what are the information that Google knows about you. But in today's talk, I'll prefer not to go in that direction. Okay. So with this internet facility, what usually we do? Usually with this scenario, the hero or heroine, whatever you say, is basically a smartphone. So a smartphone with internet is a deadly combination. And with that, you could have access to all the books that are freely available internet. You could have access to, say, Springer or Elsevier if you are a subscriber of that. Otherwise, there are plenty of freely available books that are available online. And if you take a printout of all those books, and if you place them on a library kind of thing, then the size of that library would certainly be bigger than the biggest library that is present in the world. Not only that, we can listen whatever songs that are available online freely. So nowadays, this kind of red box, these boxes are quite, at least in Salt Lake, I can see many of such boxes. But if I ask you this question, that when for the last time you have posted any of your letters inside this box, you may have gone to the post office for maybe speed post or ordinary post. But if I ask you a question, when have you posted any of your letters within this box? I mean, within this kind of box. But the post office, they do a good maintenance of this kind of boxes, though they look quite old, but still they do have a very good maintenance. But I'm sure that nowadays people, they're not that much interested to put the letters inside this box itself. So newspapers are also quite popular, but if you understand that, that has reduced. Even I can remember my childhood days when we actually waited for a long time, I mean, not long time, for the morning when the newspaper comes. And for me, I directly go to the last page to see the game news and all. But nowadays with this mobile, if anything happens, it comes very quickly to your mobile just as a pop-up. So we really do not have to wait for the next day that when a new news will come to you as through the newspaper. So it's nowadays still many people, they use newspaper, but it has reduced a lot of their importance. Like with our mobile, we can buy many things online. Nowadays, this laptop or desktops, though we do have, but for most of the purposes, what we do usually every day, we can do, or we can just use our mobile to do almost all the works that we need. So for mostly for like official purposes or making presentation or reading purposes, we use laptops or desktops. And this are mostly using this, your small mobile, this are being done by installing lots of apps. So with this apps, the whole things are so easy that a small child can operate it very easily. And now we can see that the small child, especially the small childs, they are very smart in using mobiles. They just see it, and I don't understand how they understand what to do and how to do, but they it really very smartly. So with all this, we feel very proud, we feel very powerful, and sometimes we feel very confident that, okay, with this mobile and internet, we can do whatever we want. If I go a little beyond, like almost all of us have seen this advertisement of Alexa. So Alexa is a kind of machine, and you can ask if it is connected with internet, if you can ask the questions, it readily answers you, like what is the capital of India, etc. Or sometimes it can switch on the light, switch off the light, etc. It can do it very smartly. If you go a little beyond, then in one advertisement, many of us have already seen that Sri Amitabh Bachchan ji is trying to operate the air conditioning machine of his home from far off. Say maybe from Switzerland, he is operating the air conditioning machine installed at his home, maybe at Mumbai. So the question is how he is doing so. So it's a very hot topic now. This is known as Internet of Things, IoT. So with the smart devices and all, you can remotely access the smart devices and you can operate those kind of things. So this is an example of a smart house. So here you can see that at the center, there is a machine, like centralized machine like Alexa, and all the machines here are smart, like smart TVs, smart washing machines, smart lights, smart doors, etc. You might have seen one advertisement that one guy is basically driving a car, just returning from back home from office, and he is instructing through his mobile to this central machine that I am coming back home, please prepare coffee for me. So when he reaches at his home, he gets a kind of hot coffee prepared already, because he has already instructed. Like from outside, he can instruct this machine, and through that he can instruct to the coffee machine, and coffee can be prepared, and when he will get the ready-made copy when he is at home. So in today's meeting, we are doing it over Zoom, or maybe taking classes over Google Meet, and there are many other platforms through which we could have conferences or video calls or meetings, classrooms, etc. So many things could be done. So with all this, there are plenty of such other applications where we can see that with this internet and mobile or smartphones, smart devices, we feel very strong and we are very confident. But every coin has two faces. With all these positive applications, there are lots of negative applications as well. Okay, so with the advancement of science and technology, we could have seen a lot of bad things as well. For example, this ATM skimming. So maybe around 1 year back, you could have seen in the newspaper or on the news that many of the customers, they're losing their money from the ATM accounts. Okay, so it's a very old technique, but idea is basically to installing an extra device on your kiosk. So this is basically your original ATM machine, but if that kiosk or that office is being compromised by others, though it's very difficult to do it, because in India most of the ATMs are basically protected by some person. That means some security is there to protect that. But sometimes it might happen that he might be involved with this, or maybe due to some lack of things, this could happen. Like the external or the attacker, he or may plug some of the instrument which is external instrument, where you basically punch your card. So you should punch your card here, but instead there is one extra device. When you punch your card through that device, it actually clones. That means all the informations are being copied, and there is a small camera installed here, and that camera actually captures the pin that you insert here. And there is one device which actually collects all the data that are being collected for individual customer. So when they have this clone of this card as well as the pin, they can do whatever they want. That's how many of the customers, they lose their money. So this is another example, that is the fraud of credit card. So I'm not sure whether the students, they can remember that when usually we used to have the credit card or debit card, at that point of time, at the beginning, there was no chip like golden chip. If I ask you this question, do you think that this golden chip has been installed here or inserted here due to for the sake of this decoration? The answer would certainly be no, because that is actually happened due to lot of people, they actually lost their money. So previously, the card means only the card, the back side of the card, usually the magnetic tape. And it has been found that it is very easy for the attacker to copy the information from the magnetic tape. That's why they have introduced an extra kind of golden color chip, which is basically provides you better security for cloning while you are going to clone this machine and all. So I just share with you a very true story. So it was around 13 to 14 years back. It happened in Noida. So one guy suddenly found that from his account, around 80,000 of money was gone. So he first complained it, and when the investigation started, it has been revealed that for last 2 or 3 days, his mobile was also not working. So the investigation team started working on it, and they found that the attacker somehow got hold of the card information. So getting card information is not that difficult. For example, when we go for a petrol pump, or maybe go for a restaurant for having our lunch or dinner, so we usually hand it over to the person who is involved with collecting the money. So it's not very difficult for him. Just a camera, you can make your camera on in a video mode, and in front of that, if you just put your card, then all the information which are on in front of this card is visible on that video. And if we can just switch it off, I mean just turn it off, then all the information from the back side can also be seen through this camera. So getting the information like the 3-digit number and the card number, expiry date, etc., it's not very difficult to collect. Okay, so some guy has already collected the information about that man's card. Okay, now if you do some kind of online transaction, nowadays you can see that some OTP comes to your machine or your mobile, registered mobile, and if you punch that OTP, then only the transaction takes place. Now what happened for that guy, somehow the attacker also get a SIM of the same number. For example, once it happened with me as well. I went, so you can understand that while changing the phone, so from the Nokia phone to now the smartphone, you have different kinds of SIM. So generation wise it changes. So you need to change your phone, and at the same time sometimes you need to change your SIM. So for me it was like Vodafone. I went to Vodafone mini shop and I talked with them in English very fluently, very smartly, and they changed my SIM without checking any identity of mine. Then I asked him that why did you do this? Some other person may also claim the same thing for me as well. Then see, they told very confidently, no, we can understand, we are dealing it with many people for many years, so we have some experience, so we can understand that it's only the you who can take this, and etc etc. But I told him that please do not do this. Something like that happened for that guy also. Somebody claimed on his behalf that he is that guy, so that the SIM was also given to that attacker. Now you have seen already that suppose you have a old phone with a old SIM, and suppose with the same number you took a new SIM, and if you insert the SIM to another machine, and if you just on it, when the SIM is activated, then you can see that the older SIM will not work. That means it's not like our parallel line. So when we were like your age, at that time also we did have the parallel line, the landline phone. So you might have seen some older movies where some hero and heroine, they're talking with each other over a phone, and the father of heroine is listening what is being said through another parallel line, say maybe one placed at say first floor, another one in a second floor, so that the same voice will come in the parallel line. But that is not the case in case of a mobile. So if you have a same SIM for a same number, two SIMs cannot work simultaneously. If one is activated, automatically the older one will be deactivated. So that's the usual process. So for him also it happened like the card information is already with the attacker. Now the SIM is also with the attacker. So whenever he did some transaction, the OTP came to the attacker's phone, which is the same number as the person, and he just put the OTP on the machine and he got all the money and all, etc. So he can spend things and all. So that's another important. That's why what I meant to say is that nowadays our mobile is like our identity. So we have to be very careful about our mobile. Sometimes we sell our mobile through OLX and all, but believe me, there are many techniques through which, if you think that, okay, I just formatted my phone and all the data that were installed at my, or all the data that were stored at my phone is gone. It's not the case. So there are plenty of techniques through which the data could be retrieved, and deleting data is really an art. It requires practice, and cyber forensic is involved it. So if you think that from your laptop or desktop, if you just format the data, it doesn't mean that all the data are gone. So computer had the technology, or the hard disk had the technology, it can store data for many days or many years. It depends. So it actually, there are separate aspects is there which is related to cyber forensic. So I'm not going details to that as well. Okay, so here it's basically taken from ICICI Bank website. What it says that it's quite old now, but still many people, they also lose their money through this attack. This is known as phishing attack. What it says that sometimes you may get an email, like I'm sending this email. So they basically choose it randomly. Okay, so suppose by chance you have also an ICICI Bank account. Now you are one of the customers of ICICI Bank, and you get this email from ICICI Bank. It says that we are upgrading our system, so please click here to fill out the forms so that your account could be updated. So if you click on here, it will go to another website of ICICI Bank, and it asks for user ID, password, transaction ID, confirm, etc. Whatever is basically required for transaction of money. And it happened for many customers who actually gave this kind of information to the attackers. Now, if you look it carefully, this address bar, that is very important. Whenever we do transaction, we first need to look at the address bar. It says that some number and then ICICI Bank .C0M, and it is not COM. Okay, that means it's straightforward a fake website. The previous website was correct, this link was correct, but through this link, if you click here, it will redirect to a fake website. So this link writing is there, but at the background, the hyperlink where it actually links is a fake website, and that is here. Not only that, nowadays, if you look at this in the website, that it should be HTTPS, and it should not be only HTTP. HTTP secure should be there, and it should not be only HTTP. So it is recommended that whenever you do some transaction, if you find it's only HTTP, it's recommended not to do any kind of transaction through this website. But it's, of course, it's HTTPS does not ensure you that the site that you are dealing with is not a fake one, but still HTTP, you should not do any transaction at this point of time. So this is known as phishing attack, and many of the customers, they actually lose a lot of money through this kind of attacks. So nowadays this hacking is also a very common word. So many of us, we play online games, and you will be surprised to know that many online games, they are basically malwares. Okay. So Indian government has already seen it about this, like they are already scrutinized things. They have banned many of them, and sometimes again some of it come back. For example, WeChat shared it. Many of us still use Truecaller, Beauty Plus, etc. So Indian government has found some Chinese connection with this software, so they have scrutinized it, and many of them are now being banned. Okay, so what happens with this kind of malware? So again, I'm going to give you another story, and it's a very recent story, maybe 6 months back, and many of you might have heard about it. So what, somebody gets some phone call, maybe from, say, some bank, saying that your credit card will be suspended from tomorrow if you don't do like KYC fill up. Or sometimes some people, they get phone call like your Geo number will be invalid from the next day if you don't fill up the KYC form, and so on. So basic idea is you should get some kind of a believable story. A believable story should be said to you, so that you will get some confidence about the person whom you getting this call. So what they say, that for example, suppose says that, okay, your card information, your card will be invalid from tomorrow unless you do this fill up of this KYC form. And you may find that it's already too late, the banks are closed, so you won't be at a stage to go rush to the bank. So sometimes if you believe them, they will say that, okay, there is no other option. So whatever I'm doing a favor for you. So please follow whatever instruction that I am saying to you. I will believe it. And then what they will show, they will just send you one link. They will say that, okay, this is our website link and so on. So please install this software with you. So when you install this, in between, they will send you one KYC kind of form. You will put all the detailed name, etc., bank account details, etc., and so on. And then they will send you, they will say that just submit. When you submit it, you will get a kind of OTP. They say that, okay, see, some OTP must be gone to your machine. You will see that suddenly one OTP has come to your machine, and they will ask you for the verification that you are really the genuine customer. Give me this OTP, and you will share your OTP with them very innocently. That's all. And they say that, okay, since this is a bank is already closed, we are doing this. So the charge for the whole thing would be 10 rupee only. So they will give you an account number. So you will open your Veeam account or Google Pay or whatever, or any online banking. If you have, you will just open it and you will put your PIN and all, and you will pay 10 rupee. And you will get an one SMS that, okay, 10 rupee has been paid to this account, and so on. That's all. Then after maybe within 5 minutes, you will find that 3-4 more SMS will reach your mobile saying that amount are being deducted from your, depending on the how much you have. Suppose you have 30,000, you will see that in 2 transaction, your all 30,000 is gone. You will get just after 1 minute or 2 minutes, you will get 2 or 3 messages, and all the amount is gone. So the question is, what exactly happened? So if you look at this way that they are doing, is basically they say that first install this software for our bank. So the software that you are going to install is basically, they are nowadays using 2 softwares. First one is this AnyDesk, and another one is I forget this name. So AnyDesk and Team Viewer. Okay, yeah. So another one is Team Viewer, another one is AnyDesk. So basically, these softwares are basically made to work from remote. Like suppose, so they are very well-known softwares. If you go to the Google and if you type it for any desk, that means from any desk you can work from anywhere. Another one is team viewer. That means you can view things in a team. So the name suggests that they are basically remotely placed. So you can work from a remote on any machine if that is installed at your machine. So when you install, so they will send you one link and you just faithfully you just install that at your machine. When you install that at your machine, it's done. And then you fill up the form. When you submit the form, one SMS will come to you. That means they will now ask for a permission to access your machine. Mind that most of the cases, except for few cases like Pegasus and all, most of the cases, it's basically the problem of the users who give the permission to the others to get into your mobile. Okay, it's only the user. So the SMS that comes to you is basically the access permission asked by the attacker. And you understand that, okay, I have submitted the form. That's why for verification, they are sending me this WhatsApp, the SMS. So very bravely, you just or very eagerly, you just share the OTP number with the attacker. So you just share with them. That means you are basically giving the permission to access your mobile or desktop from outside. Now the attacker will have the full control over your mobile or desktop or laptop. That means whatever you see on your phone, on the screen, message, image, everything, they can see from the remote place because you have already given them the permission to access the data. That means now you have already given, now you are paying some money, so you are opening your account. They have already, because they can also view your screen, they know your PIN and everything they know, and they will take out all the money from your account as much as that is permissible. Sometimes it's recommended that whenever you have some online transaction, so there you may put some limit on it that, okay, in one day you cannot spend more than maybe 20,000 or maybe 5,000, depending on your way of doing this. So it's better to lower down the amount of money that you want to spend, and if required, suppose you require say 50,000 of money in one go, then just manually you can increase this, and then after spending that money you again reduce the limit of spending of the money from one day on one day and so on. So that kind of things are very important, and there are many other manwares also, they are also doing the same thing, that your information are being transmitted to them without your knowledge. So there is another very important concept that is known as dark web or darknet. In this talk, I'm not going to give details of this dark web or darknet. I'm sure that many of you do have some experience of that or browser and all. I'm not going to, because it's not recommended to speak in public about this. So this is broadly speaking, so dark web and darknet basically is a part of internet. So the part of internet that usually the normal people will do is basically very small portion of internet. The huge portion of internet or the most of the part of internet is basically dark web or darknet. So if I send some email to somebody, even if you think that it is not possible to track me, it's possible. So if the agencies they want, they can find your IP address and they can track you that from this email ID or from this IP the message has been sent to that guy. Okay, that means you are very much trackable. But in case of, very broadly speaking, in case of dark web and darknet, sometimes it's very difficult to understand that to whom you are sending message or who is sending the message. Bad things, illegal things are being done in this dark web or darknet. So for example, arms dealing or many things. And sometimes you can also find in dark web and darknet there some email IDs along with the passwords are being sold maybe for $50, 100. passwords with email IDs are being sold there. So many people, they do it either for hacking purposes and all. So many things could be done using this dark web and dark net. So if you go a little further, then basically we all know that in India nowadays we can see lots of very costly cars. For example, they are fully automated cars, and in case of a fully automated cars, some small computers are there which actually associate or which actually connects with other parts of the body. For example, automated windows, automated, I mean, without any gear and all. So the cars are basically automated. And it has been found that this car could be hacked. That means the small computer could be hacked and the control of the whole car may be gone. I mean, it may happen that a person from outside can control the speed of the car, direction of the car, the movement of the windows from outside, and so on. Another very shocking news, I've taken it from a website of US. It says that the pacemaker, so when we do have some heart problems, so if our heart is not working properly, then some external support should be made to the heart, and we call it pacemaker, which actually provides you the more pumping capacity of your heart. And if it is of high-end pacemaker, then one small computer is being installed within that pacemaker to understand the situation. That means if you are running, then suddenly more pace is required, whereas when you are sleeping, less pace is required. That means the pulse of your heart should be read by some machine, and there is one small machine which is attached with this high-end pacemakers. And this report says that this pacemaker can also be hacked, but it says that don't worry, it can only be hacked if the attacker is within 100 meters of the patient. So but in near future we have no idea that how this could be exploited. So I have already mentioned about smart homes and smart houses, and you can understand that if the central system can be hacked, then whole home system can also be hacked. If you go a little beyond, then the term cyber terrorism is coming. So hacking to cyber terrorism. So I'm just going to give you an example. It's basically WannaCry ransomware attack, and it happened only for 4 days during 2017, and it happened all over the world. So what is this idea? The idea is suddenly in one day, if your machine is being infected with this virus, then in one morning when you switch on your mobile or your desktop or laptop, then this screen will appear. And what it says that, okay, don't worry, all the data stored inside your desktop or laptop are intact. We have just encrypted them. Just pay some money. For example, suppose somebody, depending on my spending power, they have sent me like $300 and send this money through this Bitcoin. Okay, so this Bitcoin is also very important term, but here we are not able to explain this. But broadly speaking, that's one of kind of cryptocurrency. If you just Google it, the price of Bitcoin may be around 27 lakhs, around one Bitcoin. But believe me, when it was proposed, like in 2008, Nakamoto, he proposed it, and it was like a 8-page paper. And the basic idea is, so when we talk about banking system, for example, in India, if you consider the banking system, then the banking system is basically governed by a central agency. In our case, it's RBI. So all the rules are basically governed by this RBI. That means some central body is there who is looking after all the transactions and all the rules that could be made. But in case of cryptocurrency, what it was proposed that there should not be any centralized body to control. That means every participant there should be independent. That means there should not be any middleman. For example, if you use your credit card, then you are basically paying through some third party, some gateway, and then some third party. Suppose you are paying some money to some merchant. Even if he is in front of you, it comes through your bank and then bank details and something, and the bank will charge some amount of money from it. That means it is basically a middleman is there who is actually taking some kind of money from you. But in case of this Bitcoin, it should be a direct transaction. And in case of Bitcoin, there are mostly, or in case of cryptocurrency, there are two kinds, mostly, very broadly speaking, there are of two kinds. One is public and another one is private. In case of public, every participant will able to see the spending or the amount of money the other has. Okay, that means it should be like a open ledger. For example, if you go compare with the bank, then if you have a bank account, then you must have a kind of passbook, and you and the people who are dealing with the bank are the only person who can see this passbook. Others are not supposed to look at your passbook. That means it's a kind of closed thing. If I am a customer, I am not supposed to look at your passbook. Okay, but in case of open kind of ledger, everybody can see who is spending how much money and etc. So that is a kind of network. But in case of private one, again, no clue about who is having how much money and so on. So in case of this kind of Bitcoin transaction, it's a private one. That means to whom you are paying the money, it's really, really very difficult to track, even for the international agencies as well. That's why when this kind of attack was mounted during this May 12 to 15, the whole world, they have to pay the money. For example, suppose if somebody will ask me to pay this money, I will say that, okay, don't worry, I have no important data is being stored on my desktop or laptop, because I have already backup of it, and I will just format it and I will get back my laptop clean. But think about if something happens with, say, some multinational company's main server. All the data are being stored there, and publicly they will not be able to announce that their main server has been hacked, because if they are going to announce this, then the whole share value will reduce a lot within maybe one day. That's why during this period of time, thousands of multinational companies, they actually paid the money to the attacker. But fortunately, it only happened for 4 days, but we never know that in near future we might have lot of this kind of attacks. And this is a kind of maps where this ransomware attack, WannaCry ransomware attack happened. So you can see that in India also it was heavily affected with this. May not be publicly, but many of the people, they had to pay the money secretly. Okay, so the very simple question is what to do then. One simple idea could be we can stop using internet. So everything is happening because all of us are connected through some internet, and if we are going to stop using internet, then suddenly we don't have any problem that nobody can get into it, so we are quite safe. But if I ask you this question, is it really possible for all of you to stop using internet? The answer, I'm sure, that will be a big no. So we require a secure digital data world, and here the cryptography comes into play. Okay, so here the term cryptography plays an important role. So here you can see that this is cryptography. So here I have written less fear and not fearless. Okay, so it's not really commutative. So we all being a student of maths, so we can understand that it's not commutative. So if I commute it, it should be fearless. But even if you use cryptography in the digital world, nobody is 100% secure. But with the help of, or the backbone of cryptography, you have less fear. Okay, so what does it mean, cryptography? What is the meaning of the word cryptography? So cryptography comes from two Greek words, cryptos and graphia. Cryptos means hidden and graphia means writing. So this is nothing but the art of writing secret message. So here some person A wants to send some message to B, and the problem is some opponent is trying to listen what is being sent from A to B. So through cryptography, it should be easy for B, because he was the indented guy to whom A wants to send the message. It should be easy for B to understand what is being sent and no one else. For example, it should not be possible for O to understand what is being sent very easily. I can never say that it is impossible, but I can always say that it should be difficult for O to guess what is being sent. So that is the idea of cryptography. So here few terms related to cryptography. So here the idea is he is the sender and she is the recipient. So this guy wants to say send some chat message to this girl. So he wants to send this message over internet. Up to this, that was not a problem, but the problem comes when a third party, a bad guy, is trying to listen what is being sent. So if he only listens what is being sent, it is sometimes it's okay. But if he has the power to modify what is being sent, that means he can modify the text that is being sent by this boy, then it will really be a problem for this boy. So he really doesn't want to send the original message to the girl directly where the boy can, this bad guy can see. So the original message is known as plain text, and the boy will convert the plain text into the cipher text using this key. Okay, this encrypted message or the keyed message will be sent through this insecure channel, that means through this internet, so that this locked message will also be seen by this bad guy. The process through which the plain text is being converted into cipher text using this key is known as encryption. Now this girl will receive the locked message or the cipher text. Now unless the girl will have some key, he will also not be able to decrypt this message. Okay, so the process through which the cipher text will be converted into plain text is known as decryption by using this key. So this encryption and decryption together, that is known as cryptography. So it's a kind of constructive one. Whereas this guy or some other guy who is always trying to listen or always trying to see any loophole of the cryptographic scheme that is being used by this boy or this person who made this cryptographic scheme. So this guys or this process of analyzing the scheme is known as cryptanalysis, and these guys are known as adversary. So these guys are known as adversaries. So at this point of time, you may think of that, okay, this adversaries means the bad guys, but that is not really the cases. It depends on the situation. It's completely perspective dependent. For example, if today, say, Pakistan government wants to talk with US government through some hotline, and some smart Indian agent or say some intelligence people, if they are going to intercept this message and going to listen what is being sent, then you will certainly not say that they are the bad guy. So it all depends on the situation. But this process, this cryptanalysis and cryptography, this together known, the topic as a whole is known as cryptology. So cryptology has two branches. One, you can say that it's a constructive one is cryptography, and the destructive one is the cryptanalysis. And for cryptology, symmetric key and asymmetric keys are two important examples. So here you can see that two keys, if these two keys are same, then we call it symmetric key, and if these two keys are different, we call it asymmetric key. So symmetric key, another name is called private key, and asymmetric key, another name is called public key. So in my talk, I will show now little bit more, little bit towards mathematics, how mathematics or especially abstract algebra. In today's talk, I will basically highlight how abstract algebra or number theory are involved in constructing this kind of schemes. Okay. So let me first give some example of this symmetric key. So it's a very long story, long back. It's around 50th BC. Okay, it's Julius Caesar. He used to fight with others, and he used to apply some kind of scheme known as Caesarian cipher. The idea is very simple. So he used to do it for Latin words, but for the sake of my understanding, I am using English alphabet. So the idea is, before going to the war front, suppose Julius Caesar is having a fight at some war front, and some of his subordinate is fighting at some other war front, which is say a little bit far off. So in between, during this war, Julius Caesar may need to send some message to his subordinate. Now, if he sends the direct message, then suddenly if the messenger will be caught by the opponent, then the messenger will be killed and the message will be lost. The opponent will understand what Julius Caesar wanted to send. That's why Julius Caesar devised a nice way. But before going to the war front, both Julius Caesar and his subordinate, they decided to have a common key. So the key that we have used here. That's why the scheme that Julius Caesar used is known as symmetric key, because both Julius Caesar and his subordinate are going to use the same key. Okay, let me explain how it is happening. Suppose we are using English alphabet and without any space. Only English alphabets are there in my original writing. Suppose my writing is cryptography is fun. So Julius Caesar wanted to send this cryptography is fun to his subordinate during the war time. But before going to the war, both of them, they had decided that in future they are going to use k equal to 11. That means this is the common key for both Julius Caesar and his subordinate. Okay, now let's see how this message will be transferred using k equal to 11. The idea is very simple. So here A to Z is there. So there are 26 alphabets. So rename them from 0 to 25. Since it starts with 25, it ends at 20. Sorry, it starts with 0, it ends at 25. So there are 26 alphabets. Now k equal to 11 means, okay, so here first alphabet is C. So come to C and the roll number for C is 2. K equal to 11 means shift 2 11 times to the right. That means add 2 plus 11, that means 13. So 11 times right means it becomes 13. So C will be converted with N. C is converted with N. Okay, 13. Now let's see what's about R. So the roll number for R is 17. And if I shift 11 times to the right, or if I add 11 to 17, that becomes 28. But the point is, after 25, I do not have anything. So you can very easily now understand what should I do. So it should be like I can come back here cyclically. So it's, if I have 28, that means 26 will be this, 27 and 28 will be this. That means R will be replaced by C. Okay, and so on. So cryptography is fun becomes this. So the messenger will carry this message to the subordinate, and beforehand subordinate and Julius Caesar, they had decided that they are going to use k equal to 11. So when the subordinate will receive this message, what he is going to do? He will just left shift the whole thing to the left to get the original message. Okay, so at this point of time, it would be nice to have interaction. Is it really possible to have interaction with the audience, or they are already muted, I guess? So any question till now? Okay, let me ask you then a very simple question. With your abstract algebra knowledge, can you frame the encryption function and the decryption function? Anybody? Is it like possible for the organizer to make audience unmute? I am sure that they are not going to do any kind of extra things, but if it is possible.
Actually, sir, they are on YouTube, so I'm not sure whether they can directly ask you questions. So
Okay,
we have thought of that they will be writing their questions in the chat box, YouTube chat box, and then Professor Gaurav Tripathi will redirect the questions to you one by one. So that is how we have thought of it.
Okay. I think those who are in Zoom, they can ask directly now. Those students, if you have any query, or they can interact. Those who are in Zoom.
Yes, any student on the Zoom?
YouTube, some students are in Zoom, they can ask.
Okay. If not, I will continue. Yeah, so, Okay, so the question is, how can I frame the whole encryption and decryption using the knowledge of abstract algebra? Of course, at that point of time, I'm sure that Julius Caesar didn't know any idea about group theory. Okay, I'm just giving you a hints. So this is an image of a clock, and I'm sure that with this hints, you are going to get the answer. For example, suppose we are going to use this kind of clock, not a 24-hour clock like that are used in Air Force or in railway station or airports. If it is only 12-hour clock, then if I ask you a question, why we do not have the hour 13? So the simple answer will be hour 13 becomes 1. After 12, it becomes again 1, 2, 3. And so 12 is basically the 0. So everything what we are doing is basically making a modulo 12. And if it is modulo 12, whatever be the number, whatever be the hour, we just make it modulo by 12 and the remainder will be the hour. That's why we never have 13 hours with this clock. We only have 1 to 12. With 12 is 0. That means from our very childhood, we are basically fond of having the idea of cyclic group. So this is an example of the cyclic group. So with the cyclic group, you can very easily construct the encryption and the decryption function. So here, X is your message, the alphabet, K was your 11, and the whole thing is the alphabet plus 11 modulo 26. So everything, all the alphabets you can think of, that is nothing but the set Z26, and decryption means Y. So minus means it should be cyclically left shift, and whatever is there you can very easily get it. Okay, and that is, I'm not going to do that. So that was very old example of symmetric key crypto system, but believe me, in today's scenario, symmetric key is also very important, but not of course Caesarean cipher. There are plenty of symmetric keys are available, which every day you are using this without having much knowledge on it. So every day, even this broadcast uses symmetric key as well as public key. So now I'm going to give you some idea about public key crypto system. Okay, so here again the same idea. This boy wants to send some message through insecure channel, and here this bad guy is trying to listen. Now, if by chance this boy and the girl, they stay far apart, for example, say opposite half of the world, then like Julius Caesar and his subordinate, they do not have any luxury to share the common key. So they cannot share the common key because they stay far apart. In case of symmetric key, both of them should be there, and in case of Julius Caesar, before going to the war front, they had decided these things. That's why they had the luxury to have the common key. But if they stay far apart, then you may say that, okay, why not then sending it by Gmail or say WhatsApp and all. Then they will receive this and they will have the common key. But if I ask you the question, if Google wants to know the key, then they will certainly get, because they are not encrypted. The keys are not encrypted. So you are directly sending the keys over Gmail. So Google, if they want, they can also get the keys. So it is certainly not a secure way of communication. And this question actually haunted many people, and people at that time thought that it is really not possible to have this kind of scheme ever. But fortunately, in 1976, Diffie-Hellman, they came up with a very innovative idea. So they actually basically the path-breaking idea, which actually gave the idea of how this could be done. So in my talk, I'm not going to give you a details, but I have chosen another one which has more abstract algebra flavor to understand. Okay, so here is the how to do so. Okay, okay. So suppose you have this boy and this girl, and if I ask you a question that who should take the initiative first to send the message, it should be the boy or it should be the girl. If you think it quite deeply, you will suddenly say that, okay, since the boy wants to send the message, so the boy should take the initiative first to send the message or type the message to the girl. But if you think it little more carefully, then you will understand that it should not be the boy, but it should be the girl, because the girl should make the infrastructure first. That means if the boy wants to send some message, for example, he wants to send the message using WhatsApp, and if the girl do not have any mobile, how the boy will send the message? It might happen that they are staying far off and the girl may not know the boy. Okay, under that situation, the infrastructure should be made. That means at least the girl should have a mobile with a valid number with internet connection and all. Then he or she should have the WhatsApp installed at her mobile. That means the infrastructure should be made by the girl first. So she should have the working mobile with a valid connection with her. Then it should be the duty for that boy to collect the mobile number to send the message. So first part is basically done by the girl to make the infrastructure. That means she is the receiver end. She is at the receiver end. So it is not the duty for the sender to make the infrastructure. The infrastructure should be made for this communication by the recipient. So now when after having this infrastructure, it's the boy's duty to get the information about the message, about the phone number. Then he will send the message to the girl. Now the point is how she is going to decrypt this, okay? Because both of them, they do not have any common key. Idea is, very broadly speaking, think about our mobile, our email ID. So when we have email ID, the email ID has two components. One is your email ID. For example, for me is abhishek.maths@presidency.in. Another one is my password. So I keep the email ID public. That means at my web page, if you go to my web page, you will find the email ID of mine. But I always keep secret the password of that email ID to get in. Okay, that means I have two components. One is my email ID, another one is my password. I keep my password with me and I make the email ID public. So here also, she will have two components. One component she is going to make public, another component she is going to keep with her. What he will know? He will get to know the public information. That means the email ID of that girl. With that email ID, he will send the email to this girl. Now it's only the girl who has the password of that email ID. It should be possible for the girl to get the message back and no one else. So that's the idea of public key crypto system. Okay. So here the only assumption here is that the password is known to only to this girl and no one else. The password of the email is only known to the girl and no one else. So that's the assumption. So that's why this public key crypto system is basically based on some assumption. Okay, let me directly come to a bit of mathematics so that I can explain RSA crypto system quickly. Yeah, let me now share my other things. Okay, so stop sharing. Again, I need to share screen. And yes, is the blackboard visible?
Yes, sir.
Okay. So basic idea here is, I'm sure that for UG1 you may not know this, but at least you have already seen Zn. You know all Zn. So this is basically the cyclic group with n elements with respect to addition. Okay. Now if I ask you why this is cyclic group, because it has some special power that some elements is here. For example, class 1 is here, who has the ability to generate all the elements of Zn. Clear? So the question is, if I ask you this question, how many generators are there? How many generators? Very simple answer will be phi of n. I'm sure that UG1 students may not know phi n, but at least you being the advanced students, you all know what is phi n. So what is phi n? Phi n is the number of positive integers less than equal to n and relatively prime to n. So for example, if I have z of say 10, and if I want to calculate phi of 10, this is the number of positive integers less than equal to 10 and relatively prime to 10. So basically, I am actually constructing some cardinality of some set. So who are the elements, positive integers, who is less than equal to 10 and relatively prime to 10? That is nothing but 1, 3, then not 5, 7, and 9. So they are the only 4 elements are the positive integer which are less than equal to 10 and relatively prime to n, and this cardinality. So phi of 10 is 4. Clear? So if this is a prime number, say for example z11, then what is phi of 11? So you can understand that all the elements 1, 2 up to 10, all of them, they are relatively prime to 11, and this cardinality is 10. So in general, you can very easily write phi of p equal to p minus 1 if p is prime. Okay, so I'm sure that you all know this fact. So it might be since all UG 1, 2, 3 are there, I'm just deriving few of the facts that would be required for my next hub. Okay. Now, if I ask you this question, if I change this from plus to dot, okay, with respect to multiplication modulo n, and the question is it a group? So your answer will certainly be no. This is a big no. So this is not a group because suddenly class 0 has no multiplicative inverse, no multiplicative inverse. Inverse. So you may say that, okay, I just remove the 0. Will that be fine? For example, suppose in Z10, if I remove 0 element, will that be fine to have a group? Of course not, because class 2 will also have a problem in having multiplicative inverse. Mind that this is multiplicative inverse. I am not talking about additive, because you will not find any A such that this will become 1. You can check. So this is certainly not a group. So only deleting class 2 and class 0 may not be sufficient. So we need to basically delete many things, especially those which are not relatively prime with 10. So if you consider if you remove all the elements which are not relatively prime, for example, class 0, class 2, class 4, class 5, class 6, class 8, so 1, 2, 3, 4, 5, 6, okay, done. If you remove all those elements, that means if you are basically having with this element only class 1, class 3, class 7, and class 9, then of course this will form a group with respect to dot, that you can show very easily, and this group is known as group of units, and sometimes it is denoted by u of n. So here in my case u of 10. Okay, so this group is known as group of units. Now if I ask you a question, how many, so sometimes it is also denoted by z of 10 star. Okay, so question is how many elements are there in z of n star, or in general how many elements are there in zn star? And a very quick, if it would be interactive one, I'm sure that you will readily give me this answer. Then the question is phi n. So very often I at the initial level in UG 1 or 2, I ask, or even UG 3, sometimes in PG students also, I ask them this question to form a question. So you can see that just now I have seen that phi n was the answer of this question. How many generators of Zn are there? So just now it is, we get that Zn plus has phi n many generators. Now I am asking you a question, how many elements are there in Zn star? Again, the answer is phi n. So it's just a side remark, but it would be a very nice way of understanding it, that frame a question whose answer is phi n. I'm not asking you a question, but I am asking you from teacher's viewpoint, that you being a teacher, ask yourself that you will frame a question whose answer will be phi n. So I'm just giving you another just so you, those who are in UG3, I'm sure that they know that automorphism group Zn and the cardinality is again phi n. So I have here already mentioned about 3 of the examples where the question is different, but the answer is phi n. So try to frame those who are in UG 1, 2, 3, whatever you know, try to find through the exercises that where if you frame some question, the answer should give you phi n. So that's quite interesting. Okay, but I don't need this one side. That's my side remark. Okay. So just now we have seen that in case of Zn star or Un with respect to dot, the cardinality is phi n. Clear? Okay. From here, a very simple theorem will be there, that is known as Fermat. You might have heard about Fermat. I'm talking about Fermat's little theorem. You might have heard about Fermat's last theorem. That's a famous one. But Fermat, he was like a different kind of people. So lawyer in general, but it's very interesting history. He was really a very interesting character. During that time, there were many famous mathematicians. He used to write them letters saying that, okay, can you solve this problem? And at the end, he says that, okay, I did this problem. If you can, I will show you. Or if you can, send me the answer. So he was trying to embarrass other big mathematicians during that time. It's a very interesting story about him, but we don't have time to discuss about it. But what it says, let P be a prime number, and A be an integer such that P does not divide A, then A to the power P minus 1 is congruent to 1 mod P. Okay, so this proof is basically very simple, and it is just one line proof. So there might be a number theoretic method of proving it, but if you know the group theory, basic group theory at least, then it is done. So just consider Z P star. So what is this cardinality? This is of phi p, and we have already seen that phi p is p minus 1. And if you know that, so let A be an integer. So let A be an integer such that P does not divide A. What does it mean? That means this A, class A, belongs to ZP star. Okay. And we know that if you raise the power to the order of the group, what is the order of the group? P minus 1. So if I have a finite group, and if so A belongs to G and order of G is finite, say n, then what is A to the power n? This is the identity element of the group. That's a very important property of a finite group. So here the identity element is 1, and that in turns give you A to the power P minus 1 is congruent to 1 mod P. But I need another definition, another important theorem that is known as Euler's theorem, which is a generalization of Fermat's-Little theorem, and that's all, nothing more. Euler's theorem. What it says, let n be, so previously we talked about only prime numbers. So here let n greater than equal to 2 be an integer and a be an integer such that GCD of a n equal to 1. Then a to the power phi of n. I have already talked about phi. This is congruent to 1 mod n. Okay, and the proof is exactly the same. So proof is exactly the same. Instead of zp star, we consider zn star, and the cardinality is phi of n. And since GCD of n equal to 1, class A must belongs to Zn star. That means class A, what is the cardinality of Zn star? This is phi n. So phi n is class 1, and this is exactly the same as this. So you can see that Euler's theorem is a generalization of Fermat's theorem, because if n is p, that is prime, then phi of p n becomes n minus 1, because if this is prime, and exactly the same as what we had in Euler's theorem. Okay, so with that, with this preliminary mathematics, we'll come to the application of a first public key crypto system. Mind that this is happening in 1978. Three famous MIT guys, Shamir, so this is known as RSA. This is Rivest, this is Shamir, and this is Edelman. Shamir is still working, and I must share with you that last December, I was the general chair, I was the program chair of IndoCrypt, the biggest crypto conference in India. And it was my great privilege to introduce Professor Adi Shamir in that conference. So he was kind enough to give a talk for 1 hour in that conference. So Adi Shamir was the person. So this is Rivest, Shamir, and Edelman. So based on their first names, the scheme known as RSA, Public Key Crypto System. And till now, you can see at many places. For example, when you are going to, I cannot show you, maybe I can show you, let me check. I need to again share another thing. So here the problem here is in Linux, it is not allowing me to share my whole screen. Okay, so for anything, so can you see my screen? Is my screen visible?
Yes, sir.
Okay, so here for anything, say for here, so in the address bar you can see one lock sign here. So if you click on that lock sign, you will find that connection secure cookies and all. So connection is secure. If you click on that, it will say about the certificate is valid and connection is secure. Learn more. If you click on that, you will find a lot of things here. Okay, if you go to the details of that, you will find that what are the things that are involved here. So out of many things, you will find that subject public key crypto system algorithm. If you put public key crypto system, you will find elliptic curve public key crypto system. There are also certificate basis, ID, and signature. If you go to the signature, certificate signature, you will find this is the signature. And all of them, they are basically based on the RSA public key crypto system that I am now going to explain you. So even Google, even this communication that we are making, we are actually using the concept of RSA that now I'm going to explain you. And believe me, whatever I have explained to you is sufficient to understand the scheme. So only the basic group theories are required to understand the scheme. Okay, so let me explain here. So again, I have to stop sharing, and again I have to select share screen. Okay. Okay, is my screen visible?
Yes, sir.
Okay, so now I'm going to give you the basic idea about the public key crypto system that was first made public key crypto system, RSA public key crypto system. So here, just before that, I have already explained you some assumption is required. Here the assumption was the password of that girl is not known to anybody. That's quite a reasonable assumption, right? Why should anybody make his or her password public? So that's quite reasonable. So in public key crypto system, an assumption is essential. So let us have a look at what could be the assumption. And you will be surprised to know that being a student of mathematics, it was quite surprising to me that, okay, that could also be a kind of hard problem in computer science. The problem here is very straightforward problem. Problem is, suppose I give you n, suppose 35, and ask you to factor it in primes. So your answer will be, it should be like p should be 5 and q should be 7. That means 5 into 7 is 35. If I ask you to factor this, you will do like this. If I ask you this, you will say that, okay, I'm not going to do it by hand. Why not? I should write a program. You will write a program and you can very easily do it very easily like this. But if I ask you to factor this, it's a pretty big number. So at the end, you have only 9. That means you cannot surely say that, you can surely say that this is not a prime. So that means it should be a product of primes. But the point is it, oh, I mean, it's not sure even. You cannot say like that also. But if I ask you to factor this, you will be stuck. Then you will say that, okay, I will write a program. You will write a program, and if you give input of this, you will also be stuck. And you will be very happy to know that not only you or your laptop or your desktop is stuck, even the supercomputer will also be stuck. So if you are going to use any kind of supercomputer till date available, that will also take more than 1 year to factor this. This is a product of these two big primes. So here this is one big prime and this is another big prime. So the question is, are they really primes? If they are primes, then how did I get these primes? Here also very interesting mathematics, mostly abstract algebra, is involved in getting these primes. If time permits, I will show you few software based things where you will able to find this big prime numbers. Okay, so the idea for public key crypto system is as follows. That means if I have this big number, I cannot factor them into two products, but if I have these two prime numbers, I can very easily factor them, I can easily product them to get this number. That means from n to pq is difficult, but from pq to n is very easy. That means it's a one-wayness. So that is the assumption, because till now we have not any good algorithm that can factor this big number into these primes using your supercomputer even. But mind that in quantum computation, this factorization is possible very quickly. The only problem with quantum computation is that the algorithm is ready, but the machine is not yet ready. That means in a broader sense, you can say that the Ramayana is ready, but Ram is not ready. Like that, here the algorithm is ready. To run this algorithm, you need a machine. But till now, no quantum machine is available to factor or to take this big prime numbers. If one day that quantum machine will be available, then factorization will be very easy using quantum machines. That's why this problem is known as believed to be hard problem, because till now no one could ever find out any of the algorithm that could break it by using the computer, even with supercomputer. Okay, so till date we do not have any algorithm to factor n into pq if these pqs are that big large. So that is the assumption for public key crypto system of RSA. So here the question was, how did I make this prime numbers, and it's a probabilistic primality testing algorithm, but I'm not going to give the details of it. But if somebody is interested, he or she may have a look at this chapter 10 of my book. So there I have given all the details of it. Okay, let's directly come to this RSA public key crypto system. So here the idea is very simple. Okay, let me just write down on the, I just switch it to my stop sharing and share my this one. Yeah, so it's better to explain over this. Okay, so this is RSA. Is the blackboard visible? Okay, is my blackboard visible?
Yes, sir.
Okay, so here is the sender, here is the, sorry, I'll put first receiver, because in public key receiver is the first guy who should start the initiative, and here is the sender. Okay, so the idea is the sender should send some message to receiver, but as I just now mentioned, it should be the responsibility for the receiver to make the infrastructure first. So what the receiver will do, receiver will choose two big primes, P and Q. So 2 means P not equal to Q. They should be of the same size. Then he will calculate phi, then he will calculate N. N equal to P into Q. Then he will calculate phi of N. See, phi of N is nothing but phi of P Q, and phi has a nice property that it is multiplicative property. If GCD of P and Q is 1, so they are two distinct primes, that means their GCD is 1, you can write it like this. And we have both P and Q are primes, so its value is P minus 1, Q minus 1. Since receiver R knows the values of P and Q, he will directly compute P minus 1 and Q minus 1 separately and make a product of it. Whatever will be the value, that will be suddenly phi of N. Mind that just like factorization, till date, no good algorithm is available to find phi n if the factorization of n is not known. Again, I am repeating, if the factorization of n is not known, if you are unable to factor it into P and Q, then there is till date no good algorithm which can calculate phi of n given n. If you know PQ, then it can be very easily calculated. But if you don't know the factors of P and Q, factors of N, then till date, no algorithm is available to calculate phi N. Then what he is going to do? He will find some E such that GCD of E and phi N equal to 1. Those who knows that if GCD of E phi n is 1, then the multiplicative inverse of E must exist. So find D such that ED congruent to 1 modulo phi n. Because GCD of E and phi n is 1, that's why the multiplicative inverse of E exists, and find that D, which is the multiplicative inverse of E. So now he has calculated many things. Now what the receiver is going to do is, the receiver is going to make public this value. So he is going to public these values. So some website or somewhere he keeps this value of E and N. So this is public. For example, in my website or in his website, he keeps like this. And with him, he will keep these things. This is secret. The value of D, he will keep secret. Okay. So two kinds of keys are used. That's why this is known as asymmetric key. Now it's the duty for sender. So he has some message. So this is the duty for sender. He has some message, he will convert this message. So first thing is that he will get the information of the public information. He first gets the value of E and N because they are public. So he will get this value. So he will have convert this message into this. So it should be open interval less than N. Then he will calculate the ciphertext as M to the power E modulo N. So M is the message he wants to transmit. He will calculate M to the power E. E is the public information, modulo N. N is the public information. He will send this C value over insecure channel to the receiver. Now is the receiver's work. What she is going to do? So receiver, she will collect C and she will compute C to the power D modulo N, and magically this is equal to M modulo N. Mind that M was chosen in such a way that the value of M was strictly less than N. So M mod N is same as integer value M because M is strictly less than N. So M mod N is simply the integer M. So he will get the value of M. Now the question is how this is happening. And here all the very simple things that we have already used are useful. Okay. So let us try to prove it. Very simple proof. Okay. So here C to the power D. What is that? So C is nothing but M to the power E. That means M to the power E whole to the power D modulo N. So this is nothing but M to the power ED modulo N. Now two things may happen. GCD of M and N may be 1. They are relatively prime or they are not relatively prime. I am talking about the case, say GCD of Mn equal to 1. There will be another case if that is not equal to 1, but this case is quite simple. Now what is ED? Note that ED was this, right? That means ED is k into phi of n plus 1 for some integer k belongs to z. Okay. Now from here you calculate like m to the power, put the value of ED. So m to the power phi of n, k into phi of n, put the value of ED here, plus 1 modulo n. That is nothing but m to the power phi of n to the power k into m modulo n. Okay. Now what is m to the power phi n? Mind that GCD of m and n is 1. Okay. And we have seen in Euler's theorem that if that is the case, then m to the power phi n modulo n is nothing but 1. So that is 1 into m modulo n, nothing but m modulo n. So we are done. So that's what we want to prove, that C to the power D modulo n is nothing but m, that we have proved. But there is another case that I am giving you as an exercise. Just please do it, and that's not very difficult one. Now the question is why the attacker won't be able to do so. The attacker won't be able to do so because of the fact that they are unable. So what are the information that the attacker knows? The attacker knows about C. C is known to the attacker because it will come through insecure channel. The attacker knows the public value, that is E and N. The only thing that the attacker doesn't know is the factorization of P and Q as well as the D. If the attacker could be able to find the value of phi n, then the attacker is done. But just now I have mentioned, if n is known and if the factorization of n is not known, then there is also no known method to calculate phi n. As a result, the attacker is also unable to do so. Okay, so only this mathematics is required to prove this RSA crypto system, and you all know this. So I had many other things, but due to this time constraint, won't be able to explain things. But just in a nutshell, I just want to show you maybe how WhatsApp works. Okay, just quickly, because I'm already, I guess, over the time. So this is just a big prime number. It's 904 digit long prime number. So I can show you how that can be in my laptop. How can I get this big prime number? It's not that difficult, but background of this is basically very simple abstract algebra that is based on quadratic residues. And the proofs of quadratic residues, basically you can prove it number theoretic way or by using the cyclic nature of this. So you can understand that how abstract algebra are being used to get this big prime numbers. And just now you have seen that RSA is being used even for this communication. So for that also similar kind of primes, not exactly this prime, but similar kind of primes are being used, and that primes could be obtained through the properties of quadratic reciprocity and all. So basically you can prove this. So in my book I have completely dealt with the things by using abstract algebra. So if you are interested, you can just have a look at that. And I have another YouTube channel. So if you are interested, you can also have a look at the group theory classes where I have shown how cryptography could be used by using, because we don't have much time today. But so this is the algorithm through which you can find this big primes even with my this small laptop within maybe 30 seconds. And now just very quickly I'll explain how WhatsApp works. Okay, so you all heard about the term end-to-end encryption. So what is this end-to-end encryption means and how it works, but I'm giving a very brief idea, very broad idea, through which you will able to understand how it works. Okay, again the same scenario, this boy wants to send some message to girl. Just now I have mentioned that it's the responsibility for the girl to have the infrastructure. That means the girl will first install the WhatsApp into her machine. When she is going to install the WhatsApp, two keys are generated. One key is the public key, another one is the secret key. The secret key is stored at her mobile, and it is stored only at her mobile, not to anybody else. But this public key is like the public information. When the boy wants to send some message to this girl, this public key is been transferred to the server. So when the WhatsApp is being installed, two keys are generated. One is public key, another one is secret key. Secret key is kept with her mobile, and the public key is transmitted to the server of WhatsApp. That means WhatsApp knows that this is the public key of that mobile number. Okay. Now, when the boy wants to send some message to this girl, then the boy sends some request to the server saying that please send me the public key of that girl for that mobile number. Then the server validates it. When it finds it is okay, then the server will send the public key of that girl to that boy. So the boy collects that public key of that girl. Using that public key, like E, in our RSA crypto system, it was E. So the message power E modulo N. So like that, he will use some of the techniques in end-to-end encryption done by WhatsApp. They also use RSA crypto system. They do like that, and they make a encryption of that message using the public key. They send this message to the server, and the server then drops that message to this girl. Now the public key is with all, but the secret key is only with that girl. Now, since the girl and only the girl has the secret key, she will able to get back the message. Now see that here the encryption is being done and here the decryption is being done. So they are the two ends, and in between server is there. Since the encryption and decryption are being done at two ends, this is known as end-to-end encryption. And what WhatsApp says, that since the private key is not with the WhatsApp, it is even for the WhatsApp to break the message. That's why this is, according to them, they say that it is very secure. But if you Google it, you will find that, or just think about some agency. For example, if FBI asks the for this key, or if FBI asks the WhatsApp to get some information about the message, I'm sure that they do it, but officially they say that they don't do this. This process is known as backdoor method, through which WhatsApp even can send the message to the third party without having any knowledge about the sender and the receiver. According to WhatsApp, if you go details of it, it says that if the message has been modified, then the key or the message will be, the changes will be seen at your, you can see that there are in hexa, there are two big information are being stored here, that actually enables you to know that something happened to your message. But according to internet, if you Google it, you will find lots of blogs which says that there are some backdoor method through which you can, the WhatsApp will actually get the information about the message. So things could be done. Okay, so I will just stop it here, and I'm thankful to Google for providing me lots of information and nice images. And I must thank to the Department of Information Technology, Government of India, DRDO, YZ, the Ministry of Defense, and DST Serve, DST Matrices, NVHM, JSPS, and JST, Government of Japan, for providing me the financial support for my research. And all the materials that I talked about is basically stored mostly from my book. So chapter 12 and chapter 10. Chapter 10 is for basically number theory, and chapter 12 is for the application of abstract algebra in cryptography. And if you wish, you can just search my name, Avishek's talk, in the YouTube. You will find lectures there on how group theory can be used, or my lectures on crypto are also available. So it's up to you. If you like, you can have a look. So that's my email ID. If I'm unable to, due to this lack of time, unable to reach you, you can certainly reach me over this email. I will try my best to resolve your queries and answer you. Thank you. So now, if you have any question or queries, I would love to answer those.
That was an amazing lecture. Thank you, Professor Adhikari, and all the attendees. I would now like to call Professor Gaurav Tripathi of the Department of Mathematics to host the question answer session and to deliver the vote of thanks. Over to you, GT sir.
Thank you, Shazidji. So far I have got two questions. One is it really possible for artificial intelligence to keep track of a large population's day-to-day activities through the smartphones?
Okay, so what I say that you will be surprised to know what are the things that I talked about, the project that I usually give it to my students, that how Google tracks us. You'll be surprised to know that from the very beginning, if you, whatever keywords that you search from the very beginning with your email ID on your browser, whatever things that you search from the very beginning, Google stores it. Not only that, I can show you a few things, like you will be surprised then. Okay, again, I need to share my screen with other things, with maybe browser. Let me open it. Okay. So I will again share. Okay, can this map, can you share, can you see this map? So this is my map, a map where I stay nearby because my mobile is with, so they can locate me. So your mobile can be very easily located. So what you are talking about this, the storing of data, right? So you can see that Don Bosco School and Presidency University, I was there. And if you go here, can you see my screen now? Is it visible, the map?
Yes, sir.
If you go to the my timeline, okay, your timeline, then you will find that exactly what I did, what are the places that I visited recently, like from here to there. Okay, so this may be yesterday's one, yesterday, like the places where I visited. But if you go here, you will be surprised to see that, for example, say maybe 5 years back, say 2017, and if I have, you can see that in 2017 I was in Moscow, Russia. So it is giving you a kind of, in say September, for example, on a particular day. So where I visited, it actually tracks me, where I walked, where I drove. So I was walking, and all the things. Now for every minutes it tracks me, and that too for last 5 years. So you can very easily understand that it's not only for last 5 years, from the very beginning with my email on, whatever I searched, it's with Google. And now the analytics could be used, and while analytics could be used, AI tools could be used there to basically characterize me, that what is my preferences. It may predict that it might happen. It happened with me in Uber. So usually after joining to Presidency University, for the last semester, when I left Kolkata, for the last semester, I used to take one classes only on Monday. So I used to go by Uber. So every day I used to go by Uber to Presidency, only Monday to Kolkata University. Every day, except for Monday, it shows me the first option was Presidency. Except for Monday, on Monday, it shows me to the Baliganj Science College. So now you can understand, within a few days, it could track me that, okay, this guy on Monday, usually his preference is to Calcutta University, not to Presidency University. Now you can understand how in detailed it tracks me or tracks you. So the question is how to avoid such things. How can you go out of this? So that's a good project. Another important question is, even if you want to go out of it, will you really be able to go out of it with your mobile with you? So that's, I think the question, if I'm not sure, I cannot get your voice. So I'm not sure whether I could answer your question. Yes, with the tools, as a tool, you can use artificial intelligence to track you, to get information, to characterize you, and to whatever you want, give the to treat you as a commodity. That I can say. Yes, maybe the next question, if it is fine with you. I'm not sure if I have could able to answer your query.
The next question is, could you brief us on how the technology of the cards with chips in ATMs provides security?
Could you please repeat the question?
Could you brief us on how the technology of the cards with chips in ATMs provides security?
Okay, so I'm not sure whether when you started using your say ATM card, it has already been changed. I am sure that you have also seen this, because nowadays when you go to the ATM, especially for SBI, it also sends you a message. It's previously we used to put the card and then punch the pin, then we get the money. Now what in recent years, maybe for last 2 years, ATM in SBI ATM cards, if you are going to withdraw some amount of money, which is maybe a more than some amount of money, then you need an OTP that you need to be inserted into the machine. So do you think that this kind of complication that actually increases the overhead, like for it is also not very convenient for the users as well? But previously when we started using the ATM, it was very easy, just punching the card, giving the pin and getting the money. But now people have thought that, okay, more security is required. That's why sometimes you can see that many of the sites, they actually authenticate you not only with your mobile, but also with your email. So it should be like both email as well as your OTP. So they validate using more and more layers. So previously it was only the magnetic tape, and with that magnetic tape, it was easier for the attackers to clone that. That means to copy the information from the magnetic tape. To make it more difficult, the card companies, they have introduced some cryptographic techniques into the chip. So when chip is inserted inside the card, the data are being encrypted. So when you punch your card, the data got first decrypted and then it starts working. So it is really difficult for the attacker to directly clone this. But as you understand, it's cryptography is like a game. Somebody wants to make some scheme and some other guy wants to break it. So in one day, again, somebody will have some better options to break it, and then company will again think about more and more technology, and in one day somebody will find with better technology to prevent that. Again, the attacker will find something, and so on. So it's a very competitive game between the attacker as well as the constructor. So that's why it's a very fast moving area. Not only mathematician here, the physicist, biologist, computer scientist, IT persons, everywhere, everybody is within this subject. That's why this topic moves very fast. Okay, is the answer, is it answering your question? I'm not sure, I cannot get your reaction. That's why I want I like the offline mode of it. So the class teaching is also good for offline one. Anyway, so is it clear? If not, please send me email. I cannot get you. Okay, any other question?
We don't have any more questions. No more.
Okay, thank you. If you have any further, so please don't hesitate to send me email. I will try my best to resolve the issues.
Am I audible? I hope I'm audible.
Yeah.
So it's like, say that I'm delighted to get this wonderful opportunity to deliver the vote of thanks. I must admit that I'm doing it for the very first time, so I don't know whether I will be able to do justice to it or not. So let me first thank Father Principal for his benevolent presence. He has been a constant source of inspiration and encouragement for conducting these colloquiums. I'd also like to thank our HOD, who, apart from serving all the responsibilities of being the head of the department, had taken this additional responsibility. She initiated this series, and I repeat, the series, not only one colloquium. And most of the success of the series rests on her shoulders. I thank all the students of the organizing committee who have worked so seamlessly that other than deciding who's the speaker, practically I didn't have to anywhere look into the matter. Maybe it making the poster, maybe sending the links, maybe creating the groups, etc. I also thank our beloved teachers whose gracious presence have made this program a grand success. I also thank the technical team of computer science department and the support staffs who have helped us so that we can conduct this in the time of pandemic to online mode. And obviously my students who after these fearsome lectures of R programming, group theory, have summed up the courage to attend the lecture. So did I forget to thank someone? Maybe. Actually, I have deliberately forgot to thank someone because I think that if I thank him, it will sound like maybe an insult. I remember calling him at the 11th hour, and in spite of his busy schedule, without the least hesitation, he has agreed to deliver his lecture. So we all are thankful to you, sir. I mean, Professor Avishek Adhikari. You have already proved that you are a great mathematician many times. And this time you have proved that you are a great human being also. We hope to get more insights from you maybe in near future. So I think I've already taken a lot of time and I'm not going to waste any more. And maybe I hand it over to our HOD.
Yeah, I think Gaurav couldn't thank himself, but I will thank Gaurav for taking all the trouble to organize the first talk of this e-colloquium series 2022. And I'd like to thank all my departmental fellow members who have definitely helped a lot in smooth execution of this webinar. Thank you all, and thanks to all my dear students and all the attendants who have attended this e-colloquium. Thank you all.
Thank you. So goodbye.
Sir,